Let's learn about the role of ultraviolet germicidal irradiation in infection control. The sun emits three types of ultraviolet rays, A, B, and C. Ultraviolet rays A and B cause skin burns and skin cancer. It is the ultraviolet C that is germicidal. The diagram shows that the ultraviolet C is stopped by the Earth's atmosphere. This means that the sunlight on Earth is not germicidal. Ultraviolet C can be generated artificially by certain lamps to create germicidal irradiation. The spectrum of radiation from ultraviolet left to infrared right is shown in the slide. The visible spectrum is in the middle. The blue bar indicates the specific ultraviolet germicidal wavelength. You can see that the UVGI is beyond the visible spectrum. Your eyes cannot see it. The purple light you see from the UV fixture is not the UVGI frequency. The glow you see does not have anything to do with the UVGI wavelength. It just means that the lamp is arcing and generating blue light. Don't rely on seeing the purple light to assume the UVGI is working. Specific measurement devices are required, which we will discuss later in the talk. The blue line marks 254 nanometers. The wavelength that has the most effective bactericidal effect on E. coli, used as a surrogate test organism. In humans, UVGI may be absorbed by outer surface of the skin and eyes. In humans, these forms of radiation can be hazardous to the cornea, causing keratitis, or conjunctiva, causing conjunctivitis and skin. You can see that the human adverse effects peak at higher wavelengths, but can still happen with exposure to 255 to 54 nanometers. The effectiveness of UVGI increases with the intensity of the radiation, here measured in microjoules per centimeter squared. Effectiveness also increases with wavelength of exposure and proximity of lamp to droplet nuclei. The installation of upper room UVGI devices in ventilated rooms has the potential to reduce TB transmission. The ventilation system here in this slide mixes the disinfected air also the contaminated air. The UV lamp is mounted high on the wall or suspended from ceiling. Radiation is directed into the upper portion of the room where air is disinfected. Ventilation system mixes this disinfected air with the air in the lower part of the room. The result is dilution of the potentially contaminated air. Per room UVGI is may be capable of air disinfection equivalent to 10 to 20 air changes per hour. Air disinfection is decreased by as much as 80% with incomplete air mixing. WHO recommendations include priority should be given to achieving adequate air changes per hour using ventilation systems. If not possible, UVGI is a complementary intervention. Upper room UVGI must be properly designed, installed, maintained, and operated. UVGI is a complementary infection control measure. It requires air mixing to be effective. More than 70% humidity may reduce the efficacy. Does not provide pressure or directional airflow. Precautions necessary to avoid short-term effects on the skin and eyes. UVGI operational exposure limit is shown in the slide. This exposure corresponds to maximum recommended irradiance of 0.2 microwatts per centimeter for 8 hours. 250 nanometers is the specific wavelength of germicidal ultraviolet light. The United National Institute for OSHA recommends that exposure to UVGI should be less than 6,000 microjoules per centimeter square over a daily 8-hour period on unprotected skin or eyes. This exposure corresponds to maximum recommended irradiance level of 0.2 microwatts per centimeter for 8 hours of exposure. Public health specialists can conduct random UVGI measurements to determine the performance of these devices. UVGI monitoring is important to ensure that the radiation level is effective for disinfecting the air and is safer for room occupants. Our routine measurements should be performed by specialist technicians. UVGI measurement devices include international light meter model with detector gigahertz optic model. UVGI must be shielded when the room is occupied. The device on the left is shielded to avoid eye damage, while the right one is not. The unit in this picture may be used flap downs when there is no one in the room. When the space is occupied by people, the flaps must be up to provide shielding. The picture shows an unshielded UV lamp in the laboratory. It is turned on when the laboratory personnel leave. Proper settings for UVGI includes large, overcrowded, congregated settings where TB is often undiagnosed. Ventilation is insufficient. Examples: casualty departments, waiting areas, homeless shelters, sputum induction booth. Upper air UVGI is suitable for particular room if there is a high ceiling, so people cannot look into the lamp. Fans or ventilation system mix the disinfected upper room air with the potentially contaminated air below. There is not much ventilation that air does not have time to be irradiated. UVGI cannot protect a healthcare worker from airborne infection occurring at a very close proximity to the patient, called as a near field. Although upper UVGI will help dilute the overall room concentration of droplet nuclei, it will have little beneficial impact on infection risks in the near field. Now we will do some real life examples of UVGI and ask you to assess whether they are being used appropriately. Now this picture shows an upper room UVGI device in the TB research room. Is this a rational location? UVGI is not useful here either. This is a picture of upper room UVGI being installed in recreation room with large windows on three sides. So given the amount of natural ventilation, UVGI is not needed here. Here is another upper UVGI device. UVGI is not needed here. The patient rooms are to the right, photographer is standing in the corridor, and there are many large open windows on the left. This is a picture of an upper room UVGI next to an exhaust fan. If the air flows too fast, then there is not enough time to do UVGI to irradiate it. So this is not proper fixation. Monitoring and maintenance is essential. Designate a person to be responsible for routinely monitoring irradiation levels, cleaning, replacing the bulbs as recommended by manufacturers, keeping records of monitoring and maintenance activities. Cleaning is very important to ensure that the device works as planned. Blue light attracts bugs and dust, so it needs to be cleaned regularly. If cleaned, the germicidal efficacy improves. UV bulbs can be cleaned with a cloth dam with a commercial alcohol-based cleaners. We are talking about upper air disinfection. UVGI can also be used in ventilation ducts. This picture shows another application. UVGI air cleaner is being tested in the multi-drug resistant tuberculosis reference center. To summarize, upper air UVGI may be capable of disinfecting equivalent to 10 to 20 air changes per hour if properly designed, installed, and maintained. Eye and skin risks can be avoided by shielding and measuring to ensure no overexposure. Upper air UVGI is a complementary intervention to adequate ventilation.